Welcome to F453 by Jam. Today we are covering Chapter 5, Data Structures and Manipulation. Let's have a go at data structures, sorting algorithms, merging data, and searching algorithms. Data structures. Data is stored on a computer as a load of ones and zeros. This isn't very useful, unless you provide a structure for the computer to interpret the data. The main difference between a static and dynamic data structure is that the size of a static data structure remains fixed while the program is running. This means that the size is known, but it can waste memory if some of it isn't required. The size of a dynamic data structure can change while the program is running. There's a higher risk of overflow if not controlled properly. However, it has more uses than static data structures and no space is wasted. A stack is a last-in, first-out data structure. Think of a stack of paper. It's dynamic, so its size can be changed while the program is running. A pointer points to an area in memory. The stack has a single pointer on top of the stack. A stack has three operations: top, push, and pop. Used to handle subroutine calls, it makes recursion possible. Top tells us the data value at the top of a stack without removing it. If the stack is empty, an error is reported. If the exam asks for an algorithm, it's important to include error handling. The top data value is the only one that can be read. Push adds an item to the top of the stack. Stacks are dynamic, but the maximum size is limited due to the size of the program, and cautions to prevent overflow. If the stack has exceeded its size, report an error. Else you increment the pointer and insert new data at the pointer. Steps 2 and 3 can be done in any order. Pop identifies the data item at the top and then removes it. This obviously can't happen if the stack is empty. The data item at the top is identified first, and then the stack pointer is decremented. A quayway is a first-in, first-out data structure. Think about a long quayway for a fairground ride. It has a front and back pointer. Its algorithms are push, pop, and front, where front is the same as top. One of its uses is in a spool quayway for printing. Push, sometimes called enqueue, the concept is generally the same as in a stack. You are adding a data item to the back of a queue. A node is a position in memory. Steps 2 and 3 can be done in any order. Pop, sometimes called dequeue, the value at the front is identified and removed. A normal queue has an unrestricted length, like a stack. A circular queue has a known maximum length. The push algorithm is shown at the right. When the tail pointer catches up with the head pointer, the queue is then full. A tree is another dynamic data structure. Think of the branches of a tree. Nodes have many child nodes. Trees with at most 2 child nodes are called binary trees, and these are the ones we'll be covering in F453. It's used in calculations, which we'll see shortly. Binary trees can be used to sort numbers. Say we want the set of numbers given in ascending order. The exam may ask for descending order, so be careful. It's really quite simple. Starting with 20, the root node, we simply check if the number is higher or lower. 6 is lower than 20, so we put it to the left. 31 is higher, so we put it to the right. 5 is lower than 20, and it's also lower than 6, so we put it to the very left. 8 is lower than 20, but higher than 20. And finally, 19 is lower than 20, but higher than 6 and 8. If you read from left to right, you will see that the numbers are in order. Sorting algorithms. In F453, you will need to know insertion sort and quick sort. With an insertion sort, you look at each element in turn and insert it into the correct position in the list. A common mistake is to move the data value down the list one by one until it's in the correct place, which is similar to a ripple sort. A sorted part of the list forms on the left side until all of it is sorted. A quick sort is slightly more complicated. A pivot is used to put lower elements on one side and higher elements on the other. Two pointers are used, the pivot pointer, highlighted in green here, which stays with the pivot, and the other pointer underlined in red, which moves towards the pivot. When the pointers meet, the lists are sorted into sublists and then sorted individually. A quick sort is faster when handling large amounts of data. An insertion sort is easier to understand and is faster for small amounts of data. If you think about it, you could use a quick sort to sort a large list and then an insertion sort to sort the little sublists. But they won't ask for this in the exam. Merging data. This deals with merging two files into one. You need an algorithm to keep ordered files sorted. Be careful and look for if it asks for ascending or descending. Merging two unordered files is easy. You just place one file after the other. When merging two ordered files, the resulting file has to be in order. Notice that Chris only appears once in file C. This is because duplicates are removed. Here's the merging ordered files algorithm from Teach ICT. If you can't remember the algorithm, break it down. Find out what must be done and how to achieve it step by step. The exam may also ask for any assumptions made about each of the files. Depending on the details of your algorithm, some assumptions will have to be made or omitted. I've listed both files aren't empty as a common assumption, even though the algorithm shown covers that. Searching algorithms. A serial search looks at each element one after the other until the item is found or the end of a list is reached. It's simple to understand in code, fast with small lists, and the list doesn't have to be in order. The size of the list doesn't have to be known either. A binary search only works on ordered lists. It looks halfway through the list and discards half of it depending on whether it's higher or lower. It keeps doing this until the data item is found or everything has been discarded. This is much faster with larger lists because half of the data is discarded each time, rather than one data item. Remember that for this to work, the list has to be in order and the size of the list has to be known. That's all my slides. Thank you for watching. Strike that like button and subscribe for more F453 related content.